Hey everyone, so in this video we are going to go over square matrices. Now we will reference what a matrix is, what a rectangular matrix is, order of a matrix and so on in this video. So if you're not familiar with those concepts, please check out some of the previous videos that we have added to this channel, and they cover rectangular matrices and they also cover what a matrix is, order of a matrix and so on. So diving straight into the topic, what you see here is a matrix. It's got 3 rows and it's got 3 columns. So it's an order 3 by 3 matrix. Now what you see here, it's a 3 by 3 matrix, which means the number of rows is equal to the number of columns. And so it's a square matrix. Like a square where all the sides are equal, the adjacent sides of a square are equal, all the sides are equal. Similarly, in a square matrix, the number of rows is equal to the number of columns. So when you look at it, you can see it's like a square, right? So let's look at a more general example of a square matrix. So you have a matrix here. A11 is the first element, A12 first row, second column, all the way down to A1m. So that tells you it's the first row, the row index is still 1, mth column, which tells you there are m columns. And then if you go down the rows, you have A11, you have the second row with A21 on, you have the third row A31, all the way down to AM1. So again you see m, but now it's the row index, which tells you there are m rows. So if you remember the video on rectangular matrices, it was m rows and n columns, where m is not equal to n. In this case, it's m rows and m columns, right? The number of rows is equal to the number of columns. Order m by m. So that's a square matrix, right? So if you call the matrix A, Aij m cross m, then I, which is the index of the row, goes down from 1 to m, and j, which is the index of the column, goes from 1 to m, right? They're both the same. So the number of rows is equal to the number of columns is equal to m. Simple, right? Square matrix. Okay, so now let's look at a few types of square matrices that you're likely to encounter at this high school level, right? So a special case of a square matrix is this matrix you see here. So what do you observe about this? You see that all the elements on what's called the diagonal, which is elements, so in this case this is A11, A22 and A33, are not 0, and every other element is 0. A12 is 0, A13 is 0, A21 is 0, A23 is 0, A31 is 0 and A32 is 0. So except for the diagonal, every other element is 0, and that's called a diagonal matrix. So let's take this more general case. It's a square matrix, m rows, m columns. So m rows, m columns. And you see that all the elements on the diagonal, and if you remember geometry, a diagonal is the line connecting the two, corners on opposite sides. So the elements on the diagonal are certain values, right? And they could be any value, but every other element, the elements not on the diagonal, are all 0. And that is what we call a diagonal matrix. Now if you're not familiar with what a diagonal is, I've just marked it out for you. So that is the diagonal, and each element there, so this is A11, this is A22 and so on. So all the elements where the row index and the column index are the same are called the diagonal elements. So if you call it Aij, then all the elements where I is equal to j are the diagonal elements. And for a diagonal matrix, the diagonal elements, which means all the elements Aij where I equal to j, are some value ki, right? And I've used ki here, which means the value can be different for different rows, right? As you get to the second row, its k2 could be different from k1. You get to the mth row, km could be different to k1, k2, k3 and so on. So they could be any values. But what's very important is that all the other elements where I is not equal to j, so A21, A12 and so on, all of them are 0, right? For a matrix, which is exactly what we saw before for a square matrix. So hopefully that's clear, right? That explains to you very clearly what a diagonal matrix is. Now what happens if each of these k's, so right now I just said that they could be any value. What if all these k's are the same, right? So example here, 3 by 3 matrix, you've got 12 at A11, 12 at A22 and 12 at A33, and every other element is 0, right? So now a more general case where again m rows, m columns, order m by m, and all the elements on the diagonal, and now you know what a diagonal is, right? They're all k, some value k, right? And in this, the example I've just shown you here, the k is 12, but some k. So now you've seen this before, the diagonal elements, the elements on the diagonal aij, where I is equal to j, that's a11, a22 and so on, are all equal to some value k. So that matrix where all the elements of the diagonal are the same is called a scalar matrix. And so aij is equal to k for I equal to j, right? So aij is some value k when I, which is the row index, is equal to the column index j, and when that's not the case, it's 0, right? Now the reason this is called a scalar matrix is because scalar means a number, right? And so k is some value or some scalar, and it's multiplied by what is called an identity matrix, which we'll just show you in a minute. And so that's why it's called a scalar matrix. And it's a square matrix, right? You're already familiar with this notation, so I'm not going to explain it again. Now what happens if the scalar, which means in this case k, is 1, right? I just told you that in a scalar matrix you can multiply a scalar with a matrix called an identity matrix, and an identity matrix is a matrix where all the elements on the diagonal are 1 and all the other elements of diagonal elements are 0. So in this 3 by 3 matrix, a11 is 1, a22 is 1, a33 is 1, a21 is 0, a12 is 0, every other off diagonal element is 0, right? So an identity matrix, and you will see this as we go into matrix algebra, matrix multiplication and so on, is used to symbolize the number 1, right? So 1 is for a single, for a single number, and so that's effectively what the identity matrix is for matrices, and it especially shows up in matrix multiplication and matrix inversion and so on. So a more general case where you have m rows and m columns, it's an order m by m matrix, and you can see here clearly all the diagonal elements are 1. So you know what comes next. I'm going to show you the diagonal elements like we have done in the scalar matrix and the diagonal matrix case. The elements aij, where I equal to j, are all 1, right? a11, a22 and so on equal to 1. And so aij is 1 for I equal to j, aij is 0 for I not equal to j, right? Simple. In the previous case, for a scalar matrix, aij is equal to k, where k is a scalar, and for a diagonal matrix, aij is some k, some ki, right, where the k could be different for each row. Okay, and so that's for a general square matrix. Okay, so now what happens if you just have one row and one column, right? It's a simple number but actually written as a matrix. That's called a singleton matrix, right? As the name suggests, singleton, so it's just one, right? So it's got one row, one column, the order is 1 by 1, m, n are both 1, ij are also 1, right? Simple. Okay, so let's now kind of clarify your concepts a little with some examples. So what kind of a matrix is this? Can you identify it? Or how would you identify this? So let's go step by step, right? First of all, the number of rows is equal to the number of columns, so we know it's a square matrix. Simple. But now what do you see? You see that the diagonal elements are non-zero. a11 is 6, a22 is 1, a33 is minus 3, but more importantly, all the other elements, a21, a12, a13, a23, a31, a32, they're all 0. So it's a diagonal matrix, right? Simple. You can't go any further because all the elements on the diagonal are not the same. Okay, next one. So that's a diagonal matrix. Next one. So what you see here, the first thing most people would probably do is go 2, 2, 2. So it's a diagonal matrix, maybe a scalar matrix because all the elements are 2, but actually it's not, because if you look here, right, 2 also appears here. A13 is 2, right? Which means the off diagonal element is not 0, which means it's not a diagonal matrix at all. It's a square matrix. It's got the same number of rows and the same number of columns, but it's not a diagonal matrix because this off diagonal element is not 0. Okay, perfect. So it's a square matrix. And now this. So I've just covered this, so you should probably all have guessed that this is an identity matrix. But how do we go at this step by step? So first of all, number of rows is equal to number of columns, so it's a square matrix. All the off diagonal elements are 0, right? So it's a diagonal matrix. Now what about the elements on the diagonal? They're all the same value, right? So it's a scalar matrix. And what's the scalar? The scalar is 1. So all the elements on the diagonal are 1, which means it's an identity matrix. So that's the best way to think about it, rather than mugging up what an identity matrix is or what other matrix it could be. Just go step by step. So if somebody tells you, oh, this is a square matrix, they're right, they're absolutely right, it is a square matrix, right? But you can go further and based on the characteristics of the elements, you can describe it in a little more detail as an identity matrix. So hopefully these concepts are now fairly clear, and to kind of cement your ideas a little more, please go take a quick test on TeachYaar.com on this topic, and I've dropped a screenshot of the test here. So you can take the test, it's a free test, and at the end of the test you'll get some feedback along with the solutions to the test. So to take the test, scan the QR code on your mobile device, or we've dropped this link, which is the test link, in both the comment section and the description section. So you can go click that and take the test. And please subscribe to the TeachYaar YouTube channel so you can get notified as we add more content.